First of all, thanks so much for having me. Thanks so much to Richard, Victoria, Andy, Mark, everybody else who's helped organise this conference. It's so fantastic to see community initiatives like this on Synapse. So yeah, thanks for having me. So I'm going to be talking a little bit about Power BI in the Lakehouse. So how do we marry this idea of the Lakehouse with using Power BI? And maybe some of the ways that we've always used Power BI and we want to continue to use Power BI. In my view, I actually think they're great together. I don't like peanut butter and jam. I do like Vegemite and eggs, which is a very weird combination. So for me, it's like that, but I would probably imagine other people have combinations that they prefer. So who am I? So I work for Microsoft as a cloud solution architect. This is a presentation I'm doing that are not necessarily the views of my employer, so keep that in mind, disclaimer, et cetera, et cetera. You can find me on Twitter, you can find me on LinkedIn. If you've got questions, concerns, want to chat, reach out on either of those channels. Happy to chat about anything. So what am I going to cover today? I'm going to cover a little bit about what is a Lakehouse design, because I think that's a term that gets thrown around by a lot of people, all over the shop, by different vendors, by different, different designs, all of that sort of stuff. So I want to kind of articulate, what are some of the ideas behind it. Then second of all, I want to talk about, how does Power BI in the Lakehouse work, and what are some of the honest challenges that exist there, and some of the gotchas, because I think there are fairly clear gotchas that you need to be aware of, and if you fit into one of those situations where maybe you're gonna it's not going to be effective, then you've got to reconsider whether this design works really well for you. I'm then going to talk about extending the lake with lake databases. So talk a little bit about this concept of lake databases that exists within Synapse and how that then works with Power BI. Finish it off with some conclusions, and I've got some time at the end for Q&A. So if you are if you're not on the Slack channel, you can join down the bottom. I've got that link. That link will be there for all of my presentation. So please ask some questions. It's really interesting to know what people are concerned about and what some of the questions are. So what is the Lakehouse? This is what I always imagined. When I first heard the Lakehouse concept, I imagined this most pristine house sitting on the lake. And the reality is that it's certainly not that pristine. It's not that clean. It's a design that helps you achieve an engineering outcome, as opposed to being one of those architectural designs that I think sometimes are very focused on technical purity or something like that. It's also a lot of marketing. So there's a lot of marketing when it comes to the Lakehouse and all this sort of stuff that I think can, honestly muddies the water sometimes, because as a term like that gets adoption, everybody becomes a Lakehouse. Everything has to become a Lakehouse. So let's drill into some terminology, because I think this is a good place to start. So the Lakehouse is the combination of the data lake being a physical layer, basically a big object store, and the data warehouse moving a data warehouse to being a logical layer, the data lake being the physical layer or the storage layer. We also hear a couple of other things. So we hear about Delta Lake, which is really just a data lake with the Delta format. So the Delta format is an open format. But it also, Delta refers to two things. So Delta can refer to the format, or it can refer, I should say, or the proprietary Databricks engine capability. So I think that's a really important thing to understand, is Delta exists as an open format, as an open file format, which is an extension of the Parquet format. But often people are also talking about Databricks Delta, which also is some of the proprietary engine capabilities. So you cannot get those engine capabilities in any other Spark engine. So it's just at least worth understanding that delta can mean two very different things depending on how you see it. So what does this sort of look like, right? Like, talked a bit in the abstract, but let's talk in sort of reality. So, most data lakes, delta lakes, whatever you want to call them, I'm going to call them a data lake because I think it's a bit more accurate and doesn't offend my sensibilities in the same way. Generally have a 3-zone layer. So some sort of bronze layer, silver layer, gold layer, if you're talking about a medallion architecture, or alternatively something like raw, cleansed, curated. Those names can be whatever you want. Some people have 4 layers in their data lake. It doesn't really matter what the layers look like, but generally what you're doing is you're increasingly refining data and getting it closer to something that is indicative of, for example, a dimensional model or something like that. So that might be sitting at your curated layer or your gold layer, something that is quite good for reporting purposes. But how do we get data in there? So we've got source systems, and in this icon, looks like a database icon, but that could be anything, right? These days, customers don't just have, a whole heap of on-premise relational databases. They might have, obviously, cloud-based databases, but they've also got other systems. So they might have Salesforce capability where you're interacting with that through REST APIs. They might have other systems like that. They might also be leveraging, if you're in the Microsoft stack, you might be leveraging Dynamics 365 in the Dataverse. So you get some of that capability to just automatically export that data to the data lake. So sometimes you've got to move that data. Other times you can very easily just get it into your raw zone or a zone inside your data lake that you can use. And inside that bronze layer, that raw layer, we're generally talking about landing sometimes Parquet files, sometimes JSON files, sometimes CSV files. Fairly mishmash of file formats, and some of that also depends on whether you're also landing unstructured data as well. Depending on what you're doing, you might be enriching unstructured data, so taking pictures and then running them through classification engines or running them through OCR technology or something like that as part of this process. And then what you start to see is, okay, we've got this raw layer, right? And that raw layer works well, like everything comes in. We need that data to be coming in generally in an incremental fashion. But how do we start to refine that? And that's where we start to move it into the silver zone or the curated zone. Those silver and curated zones are normally built on, sometimes Parquet, but increasingly what I would see now is Delta being built on. And Ginger Grant has a session 5 o'clock, I think, this afternoon on that. I will double check what that time is on working with the Delta format in Synapse. So if Delta is something that you're interested in, make sure that you come back or stay on until 5 o'clock or so. But between moving between bronze and silver or silver and gold or, the different layers, what options have you actually got to move that data and transform that data? Because we're talking about transformations. We're talking about, you've got data coming into the raw zone that might be, here's a record that updated, yesterday. If you're living in a daily batch world, I'm going to do something with that. I'm going to push that into the silver zone. I might have to update some records, do that sort of stuff. And you've really got 4 at least options on the table. And I say at least because there are tons of different ways to do this, and depending on which way you go, you can use anything. I've seen customers use Azure Functions. I've seen customers just use SQL, SQL databases to do some of this. It really depends on what you want. And obviously, there's third-party ETL tools, but in the Azure native space, I would say there's sort of 4 classic places that customers go in order to transform this. So the first one is Synapse dataflows. So Synapse dataflows, for those who aren't aware, is a Spark-based low-code, no-code ETL environment, right? So you can pick a source, you can pick some destinations, you can pick some transformations. Really great tool for those who don't want to develop any code, and very effective. And ultimately, what you're doing there is you're in an ETL tool writing Spark code. So that layer is not exposed to you, but you get the ability to have a visual tool, and it will turn it into Spark code. And one of the great advantages of that is it scales really, really well, right? So for maybe people who have leveraged SSIS in the past, scaling SSIS can be a tricky beast, I think is the polite way to put it. And so Synapse dataflows is a great technology for scenarios where you just want to transform data, just point and click. But obviously there's always limitations to any sort of GUI-based tool. So sometimes that means customers are mostly using Synapse dataflows, and maybe they're using something else for some of the other requirements. It's worth noting also that Azure Data Factory has a data flow capability. Azure Data Factory and Synapse pipelines have very similar capabilities, but not every capability that is available in one is always available in the other. And in Data Factory data flows, we do have wrangling data flows, which is Power Query based data flows. So for those who love Power BI, love writing M, love the Power Query engine, Azure Data Factory data flows can be extremely effective as a way to develop ETL in a, once again, relatively low code environment. Certainly if you're getting into writing M, it suddenly does not become as low code, but you get a lot of that capability. And for people coming from a Power BI world and becoming much more from a sort of BI analyst to a BI engineer starting to get a little bit into the data engineering space, it's a great way to leverage a whole heap of skills that you already have. One of the problems with that at the moment is that capability is not within Synapse data flows. So Power Query always sits in Azure Data Factory. And then we've got 2 other real candidates that customers are using to transform data, those being Synapse Spark. So that's the Spark engine that sits within Synapse itself. Really great integration with many of the other capabilities within Synapse. So particularly things like Synapse Link. So if you've got Cosmos DB data or you've got Dataverse data, being able to bring that data in and work with it really easily is really attractive for a lot of people. And then you've got Azure Databricks. Azure Databricks is for customers who want to be leveraging Spark with mostly code transformations. It's a fantastic technology, has many of the latest capabilities, and you can leverage that within the Synapse environment, and you can be orchestrating that all with Synapse pipelines. And I think that's probably, then what really sits over the top is, working with Synapse pipelines to orchestrate that process across the board. So orchestrating the movement of data from your source system to your bronze layer, and then through your silver and gold layer. And that also provides you with a really easy way to monitor the environment, really easy way to understand where have you got bottlenecks, where have you potentially got performance challenges. So that's what the typical, Lakehouse architecture looks like, and hopefully that sort of puts a bit of color on exactly what we're talking about. So what is the structure of a data lake? And data lakes are really just an object store at the end of the day. And by an object store, you can just throw files in it. And in the raw zone, right, generally you see a structure that's something like this. And these indentations are just folders. So you'd have a folder per system, per potentially table name, year equals a certain thing, month, day. Sometimes you go down to hour for sort of streaming IoT scenarios. And in the raw zone, that's usually last modified date. So say, for example, I'm talking about a classic retail scenario. I might have an order that is placed with one of my suppliers. So that would, happen yesterday, and then today that record changes in my ERP. So suddenly the order goes from placed to confirmed, and maybe some of the rows change. Some of the columns change as well to say I've now got an estimated ship date or something like that. I would have two records of that same order because I would have one record of it yesterday, one record of it today, and that's because it's really effective for us to write. And that's going to be something that I talk about a little bit later, is that the data lakes are often partitioned across different zones depending on what use cases there are. And that becomes really important if you want to work with things like Power BI incremental refresh, because you need to be able to effectively query your data lake to be able to pull that data out. So let's then jump into Power BI and the Lakehouse. So hopefully, that gives you a good primer on what the Lakehouse is, how it fits together, all of that sort of stuff. So we've talked about part of this equation, right? So we've talked about how data gets to this environment, what that then looks like. But how do we access data in the data lake, right? So we might be using Synapse SQL. That can be either dedicated or serverless. Most likely going to be serverless most of the time for serving data from the lake, from the data lake. That could be through Azure Databricks. So Azure Databricks it doesn't just transform data, but it also allows you to serve data out to users. And that's an area where Azure Databricks have invested a ton of money or a ton of engineering effort to develop out their SQL Analytics endpoint, which much more, basically provides you with a lot better SQL support for being able to do analytical queries across that. But you can also access this directly from a file, right? So everything that's sitting inside the data lake is just a file at the end of the day. We're talking about a series of files that all come together that bring together tables. And so, they're probably the three big ways to access data. And if we think about this from different technology point of view, if I had a Spark job that I wanted to deal with, I'm probably going to run that Spark job maybe in Azure Databricks, or I'm going to directly access those files by attaching, Synapse Spark or something to transform that data. But if I'm querying that data, I have to actually think about making sense of that data. So sometimes that direct file access is good in theory, but it really requires a fair bit of compute down the line, and that's not something that always happens. So if we think about how are we going to access it in Power BI, let's set some expectations. I expect Power BI dashboards on the whole to be fast. Less than 2 seconds response, right? The beautiful thing about Power BI is that it's an in-memory BI tool. And so users get used to being able to click and everything updates. Click on a part of a graph, things update, being able to select different time periods to be able to compare against, right? And that's the experience that most users expect from an in-memory BI tool. Whether that's your clicks, whether that's your Power BI, your clicks, your Tableau, your ThoughtSpot, it doesn't really matter what tool. That is the expectation that has been set. And that really works well when you've got an in-memory model, because Power BI is taking that data in, storing it within the analysis services tabular engine, and being able to keep that data in memory to serve user queries. And so, I/O is basically eliminated from that equation. And so that's generally what I think users want, and that's certainly what I find in most of my conversations with customers, that's what their users are really chasing. So I'm going to be pretty blunt here. Direct query on top of the data lake is pretty atrocious. And DataMonkey site.com, MIM, has published a ton of benchmarks across this. So if you want to see sort of a bit more about how bad it is, certainly check out the work that he's done. It's really fantastic. And what that really means is, okay, direct query does work. And so direct query, for those who aren't aware, is where Power BI is actually, instead of storing data within the Power BI analysis services engine, it's actually going out and issuing queries against the SQL endpoints. And that's supported with both Synapse SQL Serverless and Databricks. The problem is the performance is just simply not good enough to be anywhere near that under 2 seconds, unless you're talking about absolutely trivial queries. And so for most of the time, just because something is possible doesn't mean that it's going to create a good user experience, and that does not create a good user experience. So then we sort of start to look at in the import options. This is where we're actually saying to Power BI, every hour, every 30 minutes or whatever, do a refresh of that data. And that refresh could happen as a full refresh. So we're going to, basically do a select star from table, no where clause, just grab every piece of data that's in that table. Or alternatively, it could be an incremental update. And that's where you're sort of putting something in that where clause to say, only get us the last 60 days worth of data, or the last 30 days of data, or the last 3 days of data, or something like that, because you only want to get data that has from certain thresholds. Synapse SQL Serverless and Databricks both work extremely well for these import modes, because you're basically saying that the speed layer, so the layer that is going to deliver the speed that a user interacts with, that sort of, hopefully sub-second response, is actually being served by the analysis services engine, and you're not dependent on Synapse SQL Serverless and Databricks. There is also the capability here to be leveraging Parquet format. So for those who haven't seen, and I'm going to jump out of my into a new Power BI desktop report. And I go get data. So I can actually specify in here a Parquet file. I can use some of the advanced capabilities to sort of be a bit more clever about what files I'm going to get, because often you're going to end up with thousands of Parquet files in an environment. The problem with this is it doesn't support any form of incremental update. And it's a bit difficult to use, right? You can certainly make that better by using dataflows within Power BI. So within the Power BI service, you can create a dataflow that is picking up Parquet files. But my honest opinion is that it's one of those things that is good in theory, but probably, probably not ideal in practice. So I don't think the Parquet connector really works too well for a lot of scenarios, and it doesn't support Delta format. So if you're leveraging the Delta format here at your gold layer, you're out of luck from a file connector point of view, which can be quite problematic. Whereas, Synapse SQL Serverless, Databricks, both able to serve Delta files, both able to support incremental updates, and be able to be quite easily to be triggered. Generally, what I see is, customers who are running Databricks 24/7. So, for example, they've already got an ETL process built around Databricks, but they often have their clusters running 24/7, even if those are relatively small clusters. They're often leveraging that capability within Databricks to do the in-memory connection and do that incremental refresh. And that's just because anytime you're connecting to Databricks, you require that cluster to be up. Some of that hopefully will change with some of the capabilities in Databricks that are in development, but at the moment that can be a little bit of a bugbear for customers to manage. Whereas for those customers who aren't leveraging Databricks, primarily leveraging Synapse SQL Serverless, and that's super easy to connect to, as we're going to see quite shortly, as to how do you actually connect Synapse SQL Serverless to Power BI. So let's sort of explore what some of those options look like. So Synapse SQL Serverless, if I go to here first, we should compare this. So Synapse SQL Serverless, even though it's a special type of database, it exposes a SQL endpoint. So the serverless endpoint, you can see what mine is here. You can probably see too much information about all this, but anyway, I'll delete some things. So you can see what this this endpoint is, and I can use that with SQL Server Management Studio very easily. Doesn't zoom very well. I can also use it very easily with Azure Data Studio, which is a bit more of a modern client, but I can also leverage that within Power BI. And within Power BI, I've got a couple of different ways to connect to Synapse. And let's have a quick look at those. So the first one is I can just type in SQL and I can chuck it in as a SQL connection, even though it's a Synapse SQL serverless engine, Synapse SQL endpoint. I can just do that. That's very easy. It also prevents you from looking at the alternatively leveraging some of the workspace connector, and the workspace connector is currently in beta. Obviously, I appreciate that many to have rules that prevent leveraging beta connectors. So there's certainly the easy ability to connect to that, and then it looks like a database. And if you've followed any of the other sessions that have been run across Synapse SQL Serverless, you'd be familiar that you can very easily make it look like there's a table through the creation of views on top of that. And there's a session at, I want to say 11. Yes, 11:45 today on how to dynamically create Synapse SQL Serverless views from Synapse pipelines. So if you're interested in that approach, be sure to join that session as well. So we can do that. That all works really well. But one of the things that often is talked about with Synapse SQL Serverless is how do you make incremental updates work? Now, the first part of that, how would you make incremental updates, from Power BI just work? The first part of that is it's just going to work. Because if you're incrementing on, say, for example, order date, and even if your data lake is partitioned by last modified date, it'll still just actually work. The problem is it's not very effective, and it's going to be fairly inefficient, and to some extent that's going to lead to cost. You pay for the amount of data scanned as part of this. And so that means actually rethinking sometimes how you're partitioning your environment, because partitioning within a data lake is ideally about, when you've got a query, being able to only deal with the partition that is. So you want to eliminate a whole heap of data very quickly so that you're going to scan and read a very small subset of that data. You don't want to read data from 1991 if you want to query for what happened over the last 3 days. And what that leads to is this idea that your partitioning strategies across your different zones of your data lake should differ. At the bronze layer, you're going to be mostly writing data, right? So you're going to be ingesting data from different sources and then doing something with it to move it through the silver layer and then to the gold layer, right? So that means that you need to be very efficient for the way you want to write data in there. And that's why that last modifying date being your partition key, or basically the field that you're driving all of your sort of folder structures and your partitions by is extremely effective. And it's also extremely easy to manage, extremely easy to use. You can sort of see what data we updated yesterday or the day before. We can check what rows are coming in, all of that sort of stuff. It's really easy to work with. The problem is it's kind of hard to query, right? So if we're thinking about, okay, from Synapse SQL serverless, for example, I want to query the gold layer and I want to get every sale that happened yesterday, or every, I want to get the sum of sales that happened over the last month or whatever, something like that. That's not going to be very efficient, because I'm going to have to look at a whole heap of different partitions and I've got to remake a whole host of that mess. And even if I'd moved that into a Delta format, it's still probably not going to be terribly efficient or effective, because records can change well after the fact, right? So, maybe there's a sale that happened a month ago that there's actually some sort of, update record made to that. Maybe finally, someone paid for that sale. And so suddenly that sale is actually marked as paid. That means that you're going to have a record change. So that sale ID might change from, 2 months ago, or whatever the case might be. So it's then becomes, okay, how do we manage this in a data lake design? And that's where we start to say, okay, our bronze layer is built on a partitioning strategy that is effective and efficient for writing to, but our gold layer is probably going to be one that's really designed for reading. It's going to be designed for the sorts of queries that we're going to run. And this differs. So this might be, to continue with my sales or my order example, that might be that we're actually going to partition by order date. So we'd have that same sort of structure, but the key that is actually being used is different across this. And particularly Delta format is what makes this really achievable. Before Delta format, it was a bit of a muck around to get that to work really efficiently, and that's going to make our queries a whole bit more effective. But that also depends on the different environments. So, for example, I have I work with some customers who have got very different business units, and so sometimes they're partitioning on those different business units at a very high level, because they know that their queries are almost always business unit specific. I'm always going to be looking at the results for, I don't know, Southwest region or Northwest region. So I know what that partition, what those queries are going to look like, and therefore I'm designing those, designing my data lake to reflect the query partition, how the queries are coming in. Hopefully that makes sense. And you can kind of think about this in a very similar way to the way you might leverage table partitions in SQL, or even sometimes I like to think about it as the way I think about indexing, right? So indexing, you want to think about what are the queries that are actually going to come in, and how do you optimize for the queries that are going to come in, because otherwise you kind of end up indexing everything or nothing. You actually want to think about how are the users going to use this data? What are the questions the users are going to ask? And then how do we design structures that more efficiently answer those? So, so far it's okay, well, this kind of starts to work, right? We can do an incremental update using Power BI. We can get this data into Power BI, particularly with things like Power BI Premium. You can have really large models in Power BI data sets, so that's kind of cool. How do we extend this a little bit further, and how do we start to make sure our analysis services layer works really well with our data lake layer? So something that's been announced relatively recently, and by the way, hazard warning, if you go beyond, to continue the analogy of data toboggan, if you go beyond these bounds, we're now in preview, there's no ski patrol in the areas we're about to go to. But this is something called lake databases that exists within Synapse, the Synapse environment. So what are lake databases? Seriously, these are in preview. And I think that's really important to understand, because I'm going to be fairly critical at times about this, but this is a preview functionality that exists. So first of all, it's a CSV Parquet only option to be able to create parts of your data lake and to bring some of the database concepts of like templates and explaining how those terminologies work and everything into Synapse. Comes with a whole heap of templates. We're going to explore that. I think these templates are a little bit bonkers personally, and for a lot of companies aren't going to, it's good inspiration rather than something that you'd necessarily take those database. It has some pretty cool integration with Power BI. And the tables are shared between Spark and SQL serverless. So if you're leveraging lake databases or want to leverage lake databases, then some of the things that Synapse Spark does to automatically share these tables so that you can very easily interact between them is really cool and makes your life easier. So let's jump in and have a look at what these actually are, because me trying to explain them in the abstract is a little bit boring. So I'm here in my Synapse Analytics workspace. I can go into data, I can go new, and I can go new lake database in preview. And so I get the ability to, it's going to create a second database. So let's call this Tob, just to, be fun. I can define where this is going to be stored through the linked service. So I've already got a linked service for the database that I've got. I've got an input folder, so where in that linked service am I actually going to store that? So inside my Azure Data Lake Storage Gen 2, and then I can set the format. And this is where probably my first problem becomes that Delta is not supported. And that's just because at the moment, the tables that are shared between Spark and SQL serverless are limited to those formats. I believe that'll be something that's solved fairly quickly, particularly given as you start to explore this, Delta will make so much more sense from here. And so I've got this database. I can then kind of say, okay, what am I going to do? Am I going to create my own lake database? So I can just actually create tables as I see them. Am I going to create them from a template, or am I going to create them from an existing data lake? Now, let's have a look at this template capability. So we get a whole heap of different industries here, which is kind of cool, being able to say, I'm a retailer. And then I get a huge long list of all these tables. And what I could just do is I could go, all right, well, there's an enterprise template for retail. Why don't I just click that? So I'm going to do that. But I'm going to get 440 tables. And so that would be sort of my first criticism, is actually going to see these data models are fairly they're very enterprisey, and you can see a little view as to like how wide this thing is. It's a little bit bonkers, and so they're very enterprisey in the way that they work and the way that they're designed. And we can have a look at something here. So lead product is okay. We've got some channel information here. So we've got in here channel. It's defining the relationships for us between, what's the type of channel, what's the category, how do we distribute products in this channel, and it's developing all of these relationships for us. It also gives us descriptions, right? So we can actually have a look at this, and it's given us a table description, and that's going to, this information should come through to Power BI. I've tested this, and sometimes it's worked and sometimes it hasn't. So I think that's probably because it's in preview. So it's got a description on this, but it's also got some descriptions at an individual column level, as well as what are the data types, what does the format look like. So from this point of view, it's it's really interesting to have a look at. And from my point of view, I think this is great inspiration. I would not personally adopt this if I was back implementing these things, implementing data lakes, but I would certainly be having a look at this to say, okay, how are potentially other customers having a look at this, and what are some of the things that we need to think about? I can untick all of these and just start to have a look. What does customer look like? Like what are some of the things that we could be doing in customer? And what you're going to see is that this is really broken out to quite an extreme level. So I would say that anybody leveraging this is probably not going to be leveraging these same templates in Power BI, because they're not neat, tidy, dimensional models. And that's really what Power BI absolutely loves. Power BI loves a great, fact and dimension, very clear, and that's where you're going to also get the best performance of this. So I can do that. I can also, as I said, create my own. And one of the interesting things here is that it becomes quite easy to create partition columns. So those columns that I'm partitioning on, can be leveraged here. And then I get the ability to work with this in my different flavors of Synapse. So I can obviously leverage this in Synapse SQL Serverless, as we're going to see in a second, but I can also leverage this in Spark. So my session timed out, of course it did. But I can, I'm just in here. So this is Spark code. I can just talk about, database one and then the customer table. So I don't have to think about registering that table in Spark. It's just all magically done for me. And the other part that I can do, I go into the develop tab. I've developed a very super simple data flow here, but I can just directly insert that into the workspace DB. Now, if you don't have incremental processes though, and you're not just always doing an append operation, then you're going to need to look at this option. So I could just continuously insert values into this table, but that generally is going to, almost always is going to lead to duplication unless you've got a workload that is append only. But if you have any form of upserts, then you really actually need to be recreating that table every time because there isn't that support for Delta at the moment. So that's something to sort of keep an eye on as to how you leverage this. And then how is this exposed in Power BI? So I can click on Workspace. There is an error, there is a warning the first time you use this. I've obviously leveraged this in the past, so I don't get the error message. So I've got this database one, and you can see I can, this is coming from the customer environment, and it's got all of that description coming through, which I think is just super cool and a really nice way to ensure that you've got really neat semantic models. You've got clear descriptions at your lake, and you've got really clear descriptions coming through to your analysis services engine. So I think that is super cool. And as soon as this has Delta, I will be a much bigger fan than I currently am, if I'm being very honest. I was going to put on one part. So some conclusions. I think Lakehouse and Power BI work really, really well together. Performance can be a problem, but that needs to be managed. For real-time solutions, I wouldn't be looking at this. You can certainly look at things like streaming data flows is a great functionality that is, so that's a Power BI data flow, not a Synapse data flow, because of course we've got data flows in different places. And streaming data flows with Power BI for requirements where you need that real-time reporting is a great approach. Delta format is your friend. And I think the Lake databases show a lot of promise, but I really feel that the lack of Delta support at the moment is constraining there, noting that that is, it is in preview, it is not functionality that is being released.